So in the last video we looked at the elbow curve. So here, one way we said that we could start with the elbow point, which is at cluster 2. That is, we could probably start with having 2 clusters to start with, and that's just one way of looking at it. We could also say that perhaps we could look at the extreme end on the right and see as to which is minimizing my sum squared error. Now it could be 10, it could be 9, it could be 8. So a good way to start perhaps could be just starting with the minimum, and that we can do by selecting k optimum as one which will minimize my sum squared error, and that gives me a value of 10 for clusters, and then I'll start with 10 clusters. And a quick way to do that is do the k-means computation. I've selected only the arson from the crime types just for the sake of simplicity, and then we could also highlight the cluster points. And so this is how we get, so these diamond shapes are the center of clusters, and we can see that these are fairly superimposed, and this is obviously because perhaps we have selected too many clusters for a given set of data points and their tendency to assemble along with each other. So we perhaps need a smaller number of cluster size, and hence we would explore more alternatives. So another alternative is just to see, again we'll use the same elbow curve. So let me plot this again, and we'll see that we selected extreme right as an alternative to the elbow point. If we start tracing this back towards the left, we could see that perhaps around 3 or 4, that's probably should be the cluster size that we need, because 4 onwards or perhaps 3 onwards we don't know unless we compute, but we know that the incremental difference is not much, it's not of a practical significance. And then perhaps instead of selecting cluster size as 10, we may do well to select either 3 or 4. And a mathematical way to do that is just to do a relative difference for as we iterate through the list, and then find out which value of cluster would give us the least incremental difference from that point onwards. And so once we do that, so that's how we do it here. So let's do a rel def, which is basically subtracting error from the next element and then taking it relative to the maximum error. So I'm scaling it with the maximum of response, which is the sum squared error, and then I would select the least value of the cluster size, which makes the relative difference less than 10 to the minus 3. So that's one way to look at it. I could change the constant, and here I would probably get this value as 4. So this is a way to mathematically do it. So I arrive at cluster size 4 by comparing for each value in the array or list and checking as to what is the incremental difference if I increase the cluster size. So if my incremental difference is less than 10 to the minus 3, moving beyond 4, I would rather stop at 4 rather than going all the way to 10. That's the logic. And once I do that, I could quickly do a plot. And you can see the 4 diamond shaped cluster centers. A better way to visualize this would be to use a ready-made method, and that I got from the University of Cincinnati's website on business analytics, and it comes from a package which is specific for visualizing cluster algorithms, and the function is fwizCluster. And once I plot this, I could see the clusters in a more visually enhanced fashion, And I can see that perhaps cluster 4 is more neatly defined compared to other clusters. Perhaps cluster 2 and 4, these are slightly better. Others are superimposed. So that's one way of looking at it. And then perhaps the third option would be to enhance the previous relative consideration. Is in this case I'm using a relative weight. This is my own way of looking at it. And if I use the relative weight as an indicator, this gives me even better indication or better choice in terms of efficiency, because I don't have to look beyond the cluster size of 2. And we'll plot this as well. So I'm just limiting this to plotting for the individual aspect, because otherwise we'll have too much of grounded data points. And you can see the two diamond shapes here. And then again, I will use the ready-made method to visualize this. So that's how we get. So this is the visualization with cluster size of 2. So we can see that the first cluster tells us about the crime types which happen on location, sidewalk, street, residential area, and so on, versus crimes that have taken place in a non-commercial place, perhaps a garage, specific types of buildings, and so on. So this is one way of separating data in terms of clusters.